So you always wanted to have your own programming language, but never really done anything about it? I say, let's fix it, right? We're gonna start small and simple. Let's say we wanna be able to parse and evaluate expressions like this. For this, we're gonna start with a simple parser definition. It's basically a function, takes some input string and returns you a parsing result and the rest of the string. And our very first parser gonna be open bracket, because that's what we have here in this example. We just check the first character in the string that we get and see if it's an open bracket. And yes, it works like this. Our parsing result is a bracket itself, and then the rest of the string is a new state. Obviously, we don't want to write a parser like this for every character we ever want to deal with, so let's try to do it a bit more generic and use regex for it. So now we can redefine our open bracket parser with the regex. It still works. And then we can do a bunch of similar parsers for every term that we have in our example. We have numbers, we have spaces, and we have a plus sign. And we're gonna test it out, see if it works. If we're trying to parse plus sign with an open bracket parser, it doesn't work. It returns us a null, representing failed parsing result. Now we're trying out a numeric parser. Let's test it with a 1 to 3 string. We get a 1 as a parsing result, and we have 2 and 3 as the rest of the state, which is kind of not what we want. We want to be able to work with bigger numbers, right? And consume 1 to 3 as a whole number, not just digit by digit. So to make it work, we're gonna do sort of a parser creator function, call it oneOrMore. It's gonna take a parser as an argument and create a new parser. And in this case, a result of parsing is gonna be an array of type T, right, that we are working with. So we essentially taking a parser, running in a loop until it starts to fail. And yeah, that's it. Also, if we fail right away and we don't have any results, we also want to fail the whole parser. Now we can use this to wrap our numeric parser with a oneOrMore function and see what we get. Nice. So we get an array of digits as a separate strings. It's better than what we had, but not quite what we want. So to fix this, we're going to use a similar concept as we have in JavaScript. So we have a map function to transform items inside of the array. And here we're just going to do the same thing. We're going to take a parser, take a transformation function map, and we're going to transform the result of parser application. As usual, we run a parser, give it some initial state, then we check the result that we got. If we got null, it means our parsing failed. We want to just parse through null outside. But if it's successful result, we want to transform the result. And let's use it to create a new integer parser. So we're using our old numeric parser, and we're transforming the result by joining all the digits together and then converting a string representation into actual JavaScript number. And now we kind of able to parse parts of our expression, but we sort of want to be able to parse the whole expression, right, in a correct sequence. We expect bracket first, then we expect a plus sign, space, 2 numbers, and then closing bracket. Okay, so this part gonna be just a little trickier, less easy to follow. And I'm sure there are a lot of different, better ways to implement this bit, but in the interest of time and to keep things sort of smaller on scope, please just stay with me and it's gonna be easier to follow and understand when we actually use this function. But essentially, sequence is yet another parser creator function, right? Instead of accepting parser directly and create a new parser, it accepts a callback, which itself gonna receive a magic emit function and this emit function will receive parsers, right? So inside of this callback, we're gonna be emitting different parsers. They will be returning their results if they work out successfully. And this is how we're gonna sort of build a sequence of different parsers and combine them all together and work with their results. If during the execution of this callback some parsers fail, we want to fail the whole result. So here, for simplicity, we just have a failed flag and we're checking it all the time. And let's see how it's used. So essentially we're creating a parser for a sum expression. And here we are emitting parsers one by one. First we want to parse open bracket, then a plus sign, then a space. Then we expect a first integer, a space between first integer and a second integer, and then a closing bracket. So if any of those fails, the whole sum expression is going to be failed. Now we also want to check if left and right integers are not null, that we parse them successfully before doing something with them. And here you can see we got a 66 result over our sum expression working correctly. This was quite a lot of typing for something pretty simple. Let's add a little twist and let's say that our expressions can have expressions inside of them as operands as well. For this, we're going to add our last parser combinator, basically, which allows us to do conditional logic, right? We're going to be able to combine two parsers, left and right. All we want to do is try to execute left parser first, see if it succeeds. If it does, we just take this as a result of a new parser. If it fails, we're going to run the second parser instead. And what we can do now, we can literally describe what we want, right? Now we don't just expect an integer, we expect either an integer or another sum expression. And that's exactly what we are writing. We're going to do the same for the second operand. Now, type inference gets a little crazy because we're defining function recursively. So we want to just define the type explicitly here. And let's see if it works. It does. It still returns us 66, which I hope is the right answer. And at this point, you can do it as much as you want, right? You can go deeper. I think as much as your call stack allows you, or until you get tired. And yeah, we're testing it out with different numbers. It still seems to be working. All right, so what we just did obviously was very simple and naive implementation. And I'm sure, for example, Haskell people can make it look a lot sexier, but using the same basic principles, you can build features on top of it and get to, for example, this point that we have here on the screen, which is a small language I implemented a while back. Yeah, and this particular program actually solves Advent of Code number 9 from 2023. Let's have a look at the implementation itself of this parser. As you can see, parser combinators, pretty much what we just did, right? You have your oneOrMore, you have your many. Sequence is implemented a bit differently. We're using exceptions instead of doing null checks explicitly everywhere. Else, instead of a string as a state, we are passing around an object. This allows us to have better error tracking and have a pointer at the string where we are right now, right? So we don't have to slice the string all the time. And then this is a parser itself. As you can see, you just take a bunch of small parsers, combine them all together like a Lego to achieve the syntax of a program that you want. Here we're also defining like an error messages, so it's a little easier to debug in the actual scenario. And the main difference from what we just did in the beginning of the video is that we are not evaluating the result right away here in the parser. Instead, we are returning AST nodes. So after running your parser, you're gonna get a tree with objects like this. And later we implement a visitor of this tree. And by traversing abstract syntax tree, what you can do, you can either evaluate your language, right, or your program, or here instead, to keep things simpler, we are doing code generation and we are generating JavaScript out of our program. And so here on the left you see the custom syntax, and on the right side you see the result of compilation and generation of JavaScript. Yeah, so all you have to do now, you can pipe the file in your language into the compiler, and then you pipe the result of this into JavaScript runtime, and you get your results. So that's all I had for today. The project is available on GitHub. I'm gonna put all the links in the description, as always, all the good stuff. You know what to do. And take care.